basically in software developer, like what is good code? Good code is that solves the problem that it was made for, and it's also easy to change. So easy to change is code that is well tested and also well understood, and so it's readable. You can understand why it's written. So then you can decide whether it's time to change it or not. And both tests and commit messages, they are very helpful for that. So if some people do write comments, but comments are much worse than good naming and good commit messages, actually. Commit messages, actually, they replace, in a lot of cases, code comments.
Yeah.
So because you can
because
go
again, they express intent.
Yeah.
Hi, and welcome back to Map for Engineers podcast. I'm Vitaly Lokusta, engineering lead at Pactum. And in this episode, I had an honor to talk to Anton Keks. Anton Keks is the co-founder of Codeborne, a very special software consultancy company in Estonia. And they natively deliver software in extreme programming paradigms and style. So in their company, they always work in pairs, and they always mostly do TDD, and they follow other extreme programming practices to deliver software fast and in an agile way. And Anton is a very special guy. I personally met him and got to work with him when I worked in Starship, because Starship hired Codeborne to help with one project, and I was lucky enough to work with Anton and to pair program with him for quite a while. And I learned a lot from him, especially about extreme programming practices and how effective they can be if applied correctly. And in this episode with Anton, we covered mostly the theme about some of the practices that actually slow down teams, that slow down software engineering. And few examples are pull requests, especially if applied incorrectly, because pull requests, while ensuring the review of the code, they can slow teams down. Initially, pull requests was a very good model for open source, where it's actually a low trust environment and you need pull requests there. But for high trust environments, pull requests is not the only option. And of course, there's no silver bullet, and many teams apply PR models still successfully to deliver software fast. But we also touched on other practices that can be considered to replacing pull requests in a high trust environment. And of course, the obvious choice is pair programming. That's one of the very effective ones, especially if your team is in the office and everyone is sitting together. But also, Anton touched on a very interesting idea of daily code reviews. That's when once a day the whole team gathers together and reviews the code together. They go through all the commits of the day, and this practice usually takes 30 minutes. And we also discussed the topic of microservices, especially the anti-patterns related to microservices, when teams over-engineer sometimes and create microservices too fast, and let's say not following the Conway law as well. And on the contrary, we discussed some of the antidotes for that, and an example could be modular monolith. And last but not least, we also touched on the topic of specializing of engineers in the industry, and that it could also be very bad. We both agree that going full stack is a much better approach. It's a relatively short episode, it's 1 hour, but I had a lot of fun talking to Anton. I think we touched on a very important topic of inefficiencies in software engineering. And I somehow think and hope that I'll record one more round with Anton, because we have many more topics to discuss. And now, ladies and gentlemen, enjoy the episode. So yeah, I hope now the podcast is running. So yeah, I think we're on. Not live, like I wanted to live stream in YouTube, but we are recording.
We're still fine.
Yes. Okay, so actually for listeners to know, we want to make this podcast around 50 minutes, because Anton should go afterwards. But let me maybe start with a spoiler alert right away, what we want to talk about and what theme we want to explore. We want to explore the theme of inefficiencies in software development, right? And software engineering. And the reason is because, well, you've been in industry actually much longer than I am, and we exchanged many thoughts before, and apparently there are many similarities. And the main theme is that there is a big lack of kind of fundamental engineering knowledge and important principles and practices in the industry as a whole. And this is what we will talk about. And maybe for, let's say, around 3 minutes, could you give a context for listeners who you are, and maybe it would be interesting to explore which key events shaped your career?
Well, it's difficult to say it all in 3 minutes, but I've been a paid software developer for 25 years already, and before that I was programming myself. So I started with the computers which were like keyboards connected to the TV, basically. So my background goes back into 1994. But of course, I have gone through a lot of different languages and technologies, so I know that the important bits, these are not the things that come and go, but how do you actually approach the software development, how do you structure your code, and actually the simplicity and maintainability, these are the important principles. So I've been teaching in Teltech for 6 years. I'm a frequent speaker at software conferences. I still give actually guest lectures in both Tartu and Tallinn universities.
And you're still actively coding?
Yeah, and I'm coding because that's what I love. So in 2010 around, we founded my current company called Codeborne.
In Estonia, right?
Yeah, it's here in Estonia. We decided to do pair programming and extreme programming from the very start. We still do it for 14 years already.
All the time natively,
yes,
correct? So
yes.
all the time following TDD and pair programming.
Yeah, with TDD there are nuances, but we strive to do it as much as possible. We can talk about it as well, maybe some other time. And but what we are known for is that we are usually like one of the more expensive player on the market. So we used to work for Swedbank, like our core team, and we developed the internet bank. It was like one of the most innovative back in the years.
Hansabank.
Yeah, it was Hansabank and Swedbank. And when we decided to find Codeborne in 2010, that was the time when the economic crisis was happening, and it just wasn't very fun working at the bank at that time. So we decided to take our agile knowledge, our extreme programming practices that we were practicing for maybe 5 years already there. So we decided to go out and offer these services to others. So we've seen even inside of the Swedbank at that time that we were the internet bank team, but we were also the commando team that was saving failing projects inside of the bank.
So the bank asked your team to go and save the projects which were at the brink of the failure because they didn't know why you were effective, but they saw experientially that you were effective in delivering value.
Exactly. Right. So they knew that if nobody can make the project push forward, then this was us. So basically, we got some of the projects from different domains inside of the bank where, for example, for 3 years there was not much progress. So in the end, they ended up coming to us and asking for help. So can we push it forward? Can we start moving, basically? And this is what Agile is for, actually. So I have seen so nowadays, people think that Agile is like a buzzword and everyone is kind of doing Agile, but nobody does in reality. And actually this is something, there are also really fundamental principles that you need to follow. And one of them is the short feedback loop. So basically, whatever you do in software engineering, whether it's project management, product development, programming, whatever, you've got all kinds of feedback loops, and you need to keep them as short as possible on every level, and then you can move forward. Whatever, do you know the domain or not? Are you just exploring it? Do you know the technology or not? It's not important at all. Important is the feedback loop and quick iteration, so you learn and you move, instead of doing a half a year analysis and then failing to find out some important things that you will get stuck into 2 months down the line. So this is basically my background. So now in Codeborne we do all kind of projects. So I think in Estonia we have done a lot of software, and most of the Estonian citizens, they are using our software on a daily basis. In the banks and telcos, in energy, like everywhere.
Even in Starship Technologies, because that's how we met, right?
Yeah.
I worked in Starship in fleet orchestration team, and well, we lacked engineers, and you got there to help us with the project. And I just want to say, well, Anton and his teammate, they delivered excellently. The speed was amazing, and I learned a lot by pairing and working with Anton. So yeah, thank you, Anton, for that.
Good to hear. Yeah. And actually, we have helped a lot of Estonian startups, and not only Estonian ones. So very often when startups, they have an idea, but they don't have their own team yet to actually start doing something. Sometimes they come to us if, like, usually when we know people know us.
Yes.
So we can usually deliver the first MVP in a few months, for example, and then at the same time the companies, they start hiring, and then we bring more people in the team. We teach them through pairing, and then they can continue on their own. So very often we do this kind of things, or we are helping some larger companies to do some sub-products of their own, so that they can move faster again, or if they don't have enough focus or time to deal with something.
Right. Thank you for the introduction. And I want to ask you maybe, and that's maybe one of the main questions for today, just to kickstart that. So what do you think, what do you believe are the values, principles, and practices that engineers should follow to avoid inefficiencies, to reduce inefficiencies and waste in software development, and to make software engineering really effective?
In my opinion, nowadays, so okay, I will start maybe a little bit from the past. I think that maybe 10-15 years ago, my biggest concern in the projects that I've seen, and I see all the time. So my advantage is that through Codeborne, I see a lot of projects, like several bigger projects per year from the inside in the organizations. And the biggest problem always was, like, let's say, under engineering, or like the Codeborne coding, or that the people would just create a mess. And of course they didn't have tests. They would write a spaghetti code, and in the end it would all fall apart. So after like some time, maybe after 6 months or 12 months, they could not deliver any features anymore. They were spending too much time on maintenance, and all kind of new features. They took too much time because it did not fit into the existing code, and they did not refactor enough. So nowadays the situation has changed. It's very interesting is that nowadays I would say that the biggest problem is the over-engineering. So now people kind of, there are a lot of books now and YouTube videos and whatever, and before, like, engineers were all like starting and like learning on their own. And if you don't pair, you have nobody to learn from, and you try to like discover everything. And so you write very shitty code until you discover the patterns that actually work in a better way. So nowadays there are so much tutorials, whatever. ChatGPT is very good at writing very verbose, terrible code that actually is of the below average quality, and people just copy paste it, and they learn from it, and they think that this is the way to go. So what I see nowadays is that people are writing too much code that does too little. So in my opinion, two very important principles that are being violated nowadays is that the complexity of code should be in line with complexity of the business. So if your code is on order of magnitude more complex than the business logic that you're actually, all the problems that you're solving, then something is wrong. The same true is the opposite. If your code is like too simple compared to the business logic, then also it can be a problem with the under engineering. But over engineering is a bigger problem nowadays.
And this, to paraphrase this principle, it's also hold your thought. I just interrupted a little bit, but it's paraphrased in, let's say, domain-driven design terminology or you know, the books. Eric Evans talked about it. He said, you want to avoid accidental complexity, but only keep the inherent complexity. And then even if you have a little bit of waste of accidental complexity in your code, you want to separate it. You want to make sure your inherent complexity is not affected by a lot of accidental things that you do maybe in your infra. But yes, then you want to reduce that even to the minimum. So where you say, and this is exactly also to probably follow this principle that you say, where the complexity of code should equate to the complexity, inherent complexity of your domain or business. Yeah.
Yep. And there are a whole bunch of like practices nowadays which became the norm that actually is slowing teams down a lot. So of course, like lack of tests was always the problem. It still is. So nowadays, I think the tools are so readily available, and maybe like 15 years ago, people didn't know how to write unit tests, but now, like, you know it. Now ChatGPT can help you to learn it in one day or something, but people still don't do it. They still think that you can introduce technical debt, and from the startups we worked with, I hear it quite a lot. They say, we're deliberately introducing technical debt in order to move faster. And of course, where they get, after half a year, they are stuck in their technical debt and they are not moving at all. So and it's like, I think Uncle Bob said also, like the only way to go fast is to actually go slow.
And I mean, this is the book by David Farley, Modern Software Engineering, where the subtitle of the book is Doing What Works to Build Better Software Faster.
Yeah.
And this is true, and I think this is again re-echoed in Release It book, if you know, and also by Martin Fowler, by the way, one of my favorite articles, where he writes, I think the article, I will give it in the description in the links, guys. I think it's called something like, is high quality software worth it? And he makes a case, economically it makes sense. So it's not even a question of craftsmanship, which is another topic. It economically makes sense because this is the only way to move fast.
Sure, and if you're like producing crap, you're like, you cannot go too far. You will be stuck very very soon. And the biggest thing here, like in my opinion, is that writing better code and tests, they actually don't slow you down enough. You actually can move about as fast as writing crappy code, but down the line you'll get much better results. So you can continue for much longer. Of course, lack of refactoring is a very big problem nowadays. And if I gave a talk this year, like my talk was about the overcoming hurdles of software development. So this year I presented this at many software conferences, and I was talking about the bad practices that a lot of teams follow nowadays that actually slow you down a lot. And I would say that by far two of the worst things are pull requests and microservices. Now we can talk about it in more details.
By the way, I mean, yes, we can talk, and I agree, and especially I think it's easy to start with the second one, the microservices. Pull request.
Let's start with pull requests.
Sure. Let's actually start. May I start with maybe a setup that, and because, and I'll just share my opinion if I may. So, if I were, let's say, to create a company from the ground up, right, I would still strive for all, let's say, product engineering, whether it, again, comprises maybe a product manager, but let's say product engineers, right? To be actually physically in the office, right? And to work together, pair ideally, and to avoid pull requests, right? So what we call trunk-based development, merge directly to master. Now, we hit the reality where, I mean, even in Pactum and in many other places, we have a hybrid setup where some people work in the office, some people work remotely, or even the same person works 3 days in the office and sometime remotely. And now the interesting question for me is how to avoid the bad things about, let's say, PRs and what they create, and we will talk about, but still have effective collaboration and move as close as possible to actually what we call continuous integration, where you continuously integrate into master. So, but this is just to say that the world is not too simple, right? And it depends. But yes.
Let's start with what a pull request is.
Yeah.
So, and where do they come from? Pull requests.
From open source model.
Yeah, they come from open source model. Why is open source model different from your internal project?
Lack of trust.
Yes, exactly. Yes. So actually, pull requests are designed to actually in a situation where you don't trust your contributors. Yes. In this case, you don't merge until you review it really thoroughly. You go back and forth with all kind of feedback, and then eventually it's good enough to merge, and then you merge it. So that is when you don't trust. In the teams, when you want to work together efficiently, usually you need to have trust. So if you are working with your colleagues,
and if you don't have it, you need to build it.
Yeah, if you don't trust your colleagues, you are screwed anyway. Yes. So pull requests will not help you.
100%.
And if you're trying to apply the low trust model into the high trust situation, you don't get any benefits. You only get the drawbacks, and the drawbacks are the much longer feedback loop. And I already told you about that. Feedback loop is the short feedback, is the essential thing of efficiency.
I agree, 100%.
So basically, with pull request, what happens is that you write some code, then you create this pull requests. You already spent some time thinking about it alone, usually, if you're like people don't pair mostly. Then you publish it, and then you wait. And maybe after, like ideally, in the same day or next day, you will get some comments. And probably during this time, like normal engineers, they don't just wait. You started a new pull branch, and you started working on another feature. Yeah. Now you get these comments back, ideally after some time, but not too long. You have to again switch your focus. So you change your branch, go back to the old code.
And you pay the context switching cost.
Yeah, and then you start fixing it. And then you go through another round of review. Again, you need to switch context, and usually in my experience, I have 5 branches at the same time, waiting for feedback, and I'm juggling between them, and it's a nightmare. But the worst thing that happens also is that I cannot rely on my previous work. So basically there is no single source of truth.
Because nothing is in master yet.
Yeah, nothing is a master, so there is no continuous integration. Everyone is working on their own reality, and we are not seeing what other people are doing. Only if I review some pull request accidentally, I can see something what another person is doing. But in reality, we are not integrating, and then of course we get conflicts and whatever. And that's why people try to do very small isolated changes in pull requests, because if you change more, the review will take even longer. You will get nitpicked about commas and new lines and whatever. Instead of the real important stuff that usually, most of the reviews, they're actually not thorough enough. They are nitpicking about unimportant things. And then you just cannot do a bigger refactoring. So in order to keep your code base healthy enough, you need to refactor every day. Yeah, continuously. Yeah. Continuous refactoring is completely killed by pull request model. So if you know that you cannot do this many changes, if you do it in a pull request, you will always get conflicts. You will always be stuck forever fixing it, reviewing, and arguing about things.
I just want to say, I 100% agree. The pull requests are the biggest enemy to continuous refactoring.
Yeah, yes. And if you don't refactor, you will be screwed. So what I see right now in the projects that we actually inherit from other teams sometimes is that people don't do any refactoring. They are actively avoiding refactoring, and even if you try to suggest that maybe we do and fix that, usually the response you get, we don't have time for it right now. So, and the pull request would be too big. We need to release in 1 month. So let's just continue writing shitty code, and we'll raise a ticket in Jira that we need to refactor this.
Yes.
But of course, nobody does it. Nobody gets back to this ticket. And with most of the changes, like the clean code model, so it's usually it doesn't take much time to like pick up garbage. So I don't know. Yesterday I was walking with my dog. I saw some, I don't know, like the dog did a poo. I need to pick it up, of course, and I saw other garbage on the grass, so I picked it all up, and it's like took me like only 1 extra second to do it, and I threw everything into the trash bin. So and I forgot about it. The next second I could continue with my life. So the same in clean code. So basically, you see something is not ideal. You see a bad name of a class, of a method, function, whatever, you go rename it, you spend like 5 seconds on it, and you forget about it.
Yes.
And you commit it, you forget about it. With pull requests, it will come back to you and bite you 10 more times, because people will start arguing, it will introduce conflicts, you will be doing it over and over again, and you just don't want it. So it's impossible to keep the code clean in the pull request model, and that's why it's the absolute worst thing invented in the commercial software development.
And I want to say on this topic, by the way, if readers want to really, listeners as well, who want to really dive deeper into this topic, I read recently the book by Kent Beck, Tidy First, and there he exactly explores this the problems that PRs create towards continuous refactoring. And the book is Tidy First, that's why it is, with a question mark. Should you tidy first?
Yeah.
And that's a very, very good book, which explores these different forces, which discourage you to continuously refactor.
And then related really big problem, which is also pretty bad, is that like in my talk, actually, I start also with describing the Git. And the Git version control system, it changed the world. It's really good one. It gives you so much power, but it also gives you, it makes it too easy to do these bad things like pull requests, too many branches. And the worst thing is
long living branches, for example.
And the worst thing is the squash merge. So so the worst thing you can do with pull requests is then you squash them when they are ready to be merged. And I see now also, like already this year, last half year, I saw 2 big projects where actually people were insisting that we would squash the pull requests into one commit.
Where, let's say, it's even to the point of convention.
Yeah, and it's so bad, is that basically when I do work, of course I see a lot of people also not writing good commit messages, writing like doing shitty commits, doing like fix test, fix code, and you get like a whole bunch of commits like this. Of course, these are useless commits. So you don't have, or like you in your team, when you're collaborating, you have the continuous code ownership, continuous collective code ownership, also like defined by Ken Beck in Extreme Programming. So this means that there is no my code or your code. It's our code. We as a team keeping it clean. We're trying to improve it all the time. And I lost my...
we talked about Git and the squash and merge.
Yeah, and even with squashing, actually, you write good commit messages. You need to like collaborate with your team to teach others to write good commit messages. And commit messages should respond to the question why.
They should express intent.
Yeah, it's not the question of what, it's a question of why. Because I see from the diff what. I see that you have like created a new class or renamed something or whatever. But why? So it's always good. Yeah, it's good to have maybe link to some, I don't know, user story or something. It's always helpful, but you need to also explain, like in a human language, why was it done? Why was your decision like that? If you're, especially if you're doing some maybe not obvious change in the code, it happens a lot that you are doing something. For example, you found some problem, you needed to do a workaround for some like problem in your code or in others' code, in the libraries, whatever. You need to explain very thoroughly why did you have written code like this, and then after 1 year, me or another person would stumble upon this code, and they will have a question why. And if usually In my projects, I do the git blame in IntelliJ annotate. I see a very small commit and with a good explanation why this line of code is here, and it is really helpful. So sometimes this line was changed also several times. It's very easy nowadays to go back several commits and actually see where this code was introduced, when and why. And then you have your answers, and then after that you can make a decision. So is it code still relevant? Maybe you should change it. Maybe you should throw it away because like the library that was worked around has been fixed, or like whatever, like the market situation has been improved in terms of like business logic. And then you go and fix it, and you know why it was done. So in case of squashed commits, you see a huge commit with like non-descriptive message. Sometimes it will have a very long commit message which is composed of all the other fix messages which are not helpful at all. And then you don't have the answer why.
So the important principle to keep with why keeping commits is important is to translate on this correct level of granularity of commit the intent of why certain change was made.
Yeah, and they should be small, and then you can like be much safer. So basically in software developer, like what is good code? Good code is that is solves the problem that it was made for, and it's also easy to change. So easy to change is code that is well tested and also well understood, and so it's readable. You can understand why it's written. So then you can decide whether it's time to change it or not. And both tests and commit messages, they are very helpful for that. So if some people do write comments, but comments are much worse than good naming and good commit messages actually. Commit messages actually, they replace in a lot of cases code comments.
Yeah.
So because you can
because
go
again
and,
they express intent.
Yeah. And if you follow this principle and you do refactor as well on a daily basis before introducing every feature, and you commit it separately, you will have a very healthy code base for years to come. So you can, you will never tell your customers, say, sorry, we have a technical debt, so please give us 2 months so we can fix it. So it's always, in my opinion, this worst thing, like the most unprofessional thing that can happen to a project.
To stop the world and start refactoring for
if
2
you
weeks.
like tell your customer that you need to refactor things or you need to fix the technical debt without like adding new features for some time, it's like really bad situation. Doesn't make us look good.
I agree. So just to maybe summarize, or for me to paraphrase what you mentioned, and for us to a little bit step back and see where we are. So you mentioned two not good things happening or bad practices that you observe. Is one related to PRs and second microservices, right? And in terms of PRs, so the problem, again, PRs were created for the environment where there is a lack of trust, which is open source, and there I would say they work effectively, right?
These are needed.
They are needed
because of the situation.
Exactly, yeah. And it's reasonable that in open source you don't just allow everyone to merge the master. That would be a disaster.
And I would even say that maybe PRs can make sense in case you like introducing a new team into your project, like maybe even an external team. Maybe PRs can work initially for quite some time, but you need to understand that it is temporary measure until you build the trust.
Okay. And let's say, again, the team, if we talk about a highly cohesive team, which feels like, again, strong psychological safety, they agree on the principles. And that's an important thing, by the way, I think, for the team to agree on values and principles that they align on. And once it is in place, it's a high trust environment. There, you don't want to use PRs because, again, they're the biggest enemy towards continuous refactoring. What would be the antidote against, so not using PRs, but what?
Yeah, a lot of people say that we do PRs because we need to do code review. And there are a lot of other ways how to do code review.
Yeah, and exactly. I just want to say one of the ways why people say it is also not because they want to, but because it's a compliance requirement. For example, SOC 2 compliance.
But it's completely normal thing to review. Like nobody should be working alone on very important things. Even I did agile trainings to even lawyers, and even lawyers they pair when they write really like important parts of the texts.
That's a very good point. Yes.
So yeah, nobody should be allowed to work on something alone.
Yes.
So,
If you build also software for Rocket or anything business critical, you want to be two pair of eyes on that.
and the best way to not to work alone is to pair. So pair programming actually solves most of the problems we're talking about right now.
And you make commit, you merge the master.
Yeah. So not
Without
you
the
merge,
branch.
like you just go and commit into master or main, whatever how it's called nowadays. So yeah. But so basically, yeah. What is pair programming? Pair programming is defined by Ken Beck as extreme code review. So it's actually code review 100% of the time.
Continuous code review.
Yeah, continuous code review. Yeah. So yeah, getting it out of the way, what are the other ways to do code review? You can do it, for example, even we in Codeborne, when we have larger teams, let's say like 6-8 people, then you don't maybe pair enough or you don't see all the code frequently enough. So it can happen. So you work in one place, you then pair with another person, you work in another place, but you still don't see everything. So and it's good for the collective code ownership to like get more and see more of the code base
on a continuous basis, more or less, on a weekly basis.
Yeah.
Let's say.
So in some cases we do the practice of after the fact daily code review. And it's not as time consuming actually. It's definitely much more efficient than pull requests. So basically we do it, for example, every day at let's say 6 or like 4 p.m. You just sit with the whole team in the meeting room and you go through all the commits on the main which were done this day.
So you do it at 4 p.m.
Yeah, for example. You can do it in the morning and review the previous day. It doesn't matter. So whatever works well for you, and you can even do it with the remote developers as well. You just, again, like connect them with the Zoom, you share the screen, you go through the commits. And usually we do it the way that people who made the commit, they even really quickly briefly like describe
context,
it themselves.
Right?
Yeah, well, what they have done. So we very quickly go through the diff. We see, okay, that is that thing. So everyone gets on the same page. Everyone can like comment on improving it. So then very often after this meeting, there is a small to-do file is being created and also committed actually. With small like ideas, what can you improve? So
during this, I want to elaborate on that. So during this meeting, you create a new to-do file, like in Markdown, right?
Yeah.
In Markdown, and let's say you go through the commits, and you notice like, oh, it would be nice to follow up on this, or do this. You write it in to-do.
Yeah, so some of the things are nice to have. Some of the things are like, okay, this is definitely a bug. Okay, let's definitely fix it tomorrow. So like a first thing tomorrow. So sometimes it can happen. Even with pair programming, it can happen that some third person will see something that the two did not see. It's a much more rare case than when people working alone, but it still can happen. So
I just wanted to throw a joke and say, why don't you create Jira tickets instead of to-do? But that was a joke saying that creating Jira tickets is extremely slow and you will not do it.
You don't get me started on Jira.
Let's not get into Jira. But on this to-do, it's important, and I want to follow up on this whole life cycle. So you create a to-do, you write their follow-ups, and mostly, again, this follow-ups, this is not something that you manage over a long period of time. This is something where in 99% of cases, you will follow up the next day, or create in your backlog some ticket if it's a larger thing and you need to discuss with the client or whatever, aligning the team.
If it's a business issue, then usually it should go into whatever user story tracking tool you have. Hopefully it's not Jira. The to-do list, you keep it short, and why it's in the code, because when you like fulfill it, you remove it from this to-do file in the same commit. And then the next day you see during this code review, you see, okay, this item was gone, and with these kind of changes. And that actually, usually this meeting, you can do it in maybe, let's say, half an hour. So half an hour per day is, it's a much better price to pay than usually people spend more time per day on pull requests, on reviewing them and going back and forth and whatever. And of course, it also like means that the style changes. Of course, you can always also commit on the style changes, but basically you need to like agree on a common common ID setup and formatting and whatever, so that you don't spend time like talking about formatting.
May I ask you about the dilemma now? And it's like from the real world, because again, I want to like kind of throw you some problems from the real world and for us to discuss how to practically solve them. So first of all, by the way, I really like this idea and I don't hear about it too often. Not too many people talk about it, but this seems to be a very good idea, and which is working even in a hybrid environment when people work, some of the people work remotely. Now, my question is the following. If you follow a continuous delivery where every commit triggers the pipeline and deploys to production, right? Actually, in Pactum, we follow that. Every merge to master ends up in the production deploy automatically. We don't have a manual release button. But now we have a little bit of dilemma, because from compliance perspective, we promise well to our customers and to audits, you know, and it's not even like about Pactum, but in any kind of organization, you say that your code will not be in production. You don't have any code in production which is not reviewed at least by 2 people, right? Or 1 person. So 2 people, there are 2 pair of eyes on it. How do you solve that? Because if you during the day, you review already what you committed, and what you committed is already in production, now how do we solve that?
We use pair programming for that.
Okay.
So,
yes.
but actually, I can say that we, in most projects, we don't use continuous delivery to production. I would say we use continuous delivery to demo or test environment. So usually all our, like every commit reaches the demo environment which is instantly visible for all the parties, for the product owners, all the stakeholders who want to get the stuff done. But every small commit is probably not worth it getting into production. So because we do like, I do like, I don't know, 30, 40 commits per day. So
yes.
Or like, but the order of magnitude is like this. So maybe it doesn't make sense to deploy it to production like 40 times per day. But we deploy it to the demo server, of course.
Yeah.
So that is essential. And there you actually, of course, and all your tests run through every commit. So the continuous integration server is still there. So and you deploy it somewhere. And for the production deploys, we usually do it, let's say 1 or 2 times per day, maybe, sometimes maybe even 2 times per week, depends on the business needs. So for example, if we have fixed an important bug, of course our main branch is always deployable.
Yeah.
So we just don't do it all the time.
Yeah. Let's say it's always in a deployable state, which is important, the main characteristic of continuous delivery. But you choose when to actually release and deploy.
And so basically we push a button maybe 1 or 2 times per day, like when we want to actually deliver stuff, when we have created enough of value to actually deliver it. So and I think that's okay. So deployment to production is also okay, but yeah, there are some smaller risks associated with it. But of course, you always need to have a good test coverage to do any kind of continuous delivery. So it's just impossible without it. And those people who also skip the tests, which is like also if we look at the Maslow pyramid of the software development, the tests are on the base there and the lowest level. So if you don't have the test, you cannot like reason about software quality at all. So you just. The worst thing that can happen with your software project is that you are afraid to change your code.
Yep.
And if I hear people saying that, then I see immediately that there is a big problem that needs to be solved.
Yeah, if people are afraid to change code, and I like this is what Robert Martin said once, it means that the code owns them, not they own the code.
Yep.
And this is a big problem because then you have psychological barriers to do anything, to change the code in any way. And this is where your project gets rotten and die.
And it will kill your refactoring efforts. You will never refactor because you'll say, oh, who will test it? So I heard it in my current projects now that I have joined 3 weeks ago, that people say that, hey, who is going to test it if we refactor this and that? I say, like, there's no problem, let's write tests.
So we have around 7 to 8 minutes. I know you should go soon.
Let's get into microservices a little bit.
Let's do it. But may I still get to the model that we use? And I'm not saying it's right, but this is something that, let's say, I don't know, I invented, or let's say that we as a team iterated on and came through right now through many retros and reflections. So we do use PRs, but we are very well aware of the problems with PRs. We know that they're kind of our enemy in some sense. They are the means to an end, and yes, they do help, let's say, first of all, to tick off this box with compliance, and we still use it because, again, it was again from the start that every commit ends up in master. So we have those things. But one way how we counteracted the problems with PRs, and I'm not saying it's ideal, in no way. And by the way, I want to actually combine it now with this daily code reviews that you mentioned. But what we do, let's say if our team is, just to give an example, 6 engineers, let's say, during any week, we will most likely pair on topics by 2 people. And inside this topic, which usually we want to keep at most, let's say, at 1 week, not longer. It could be less, depends. Some things could be 3 days, 2 days. And as we know, estimates are, always incorrect, no matter how hard you try. That's why obsessing over estimates, it's another conversation.
No go.
But I wanted to say that we pair on it, and this pair decides how they work. And most of the time, if they're in office, you will pair program, right? But the good thing is that they know very well the context of what you're doing. And they're very interested to review each other's PRs very fast. And this works, actually, because both are responsible for the delivery of this, and both agree how they work, and they both, so to speak, loaded into their memory everything that needs to be done. And what's important there, even if they review PRs, it's a very contextual and relevant feedback. It's not about some nitpicking now. And they do it fast because, again, they want to merge to master to, all have the same line. And what we even do, we employ a lot of feature flags where even if, let's say, 2 people work for 3-4 days, we will invisibly merge our work to master, even if it's some changes under the feature flag, so that you can keep the, keep integrating into the master. And again, I'm not saying this is the way. This is what works in our team right now. But again, I want to say and stress that I really like your approach, if possible, to do this daily code reviews. And actually, I want to try it at least for a week in my team, because this seems to be very interesting.
In my previous project this year, there was also a requirement for pull requests, but we settled on a way of doing it that would not actually slow us down too much. And we settled on a daily pull request.
Daily.
So basically, whatever we do during the day, every evening we create 1 pull request, and the next morning somebody will review it and merge it. So basically, but it's essentially the same as daily code review.
Right.
So, but we get this compliance check, and everyone is happy. Okay, we're still doing pull request, but in reality we are not. In reality, we are actually integrating all the time.
But you're integrating into this one branch that you created, and then And I just wanted to say, by the way, in our case, we were conscious to keep the iteration time of the PR reviews to keep it very fast review time. And this was one of the most critical things, because as you said, one of the problems appears when your times get bigger. Like, this is your biggest enemy. If, for example, no one reviews PR and then you context switch, this is the worst thing that can happen, right? And this is where also all the evilness from PRs come from.
Yes.
Yeah.
So
microservices. Yeah. In 3 minutes.
And then actually microservices, if you employ both pull request and microservices, that's the worst place to be in the world.
I cannot agree more.
So let's say, why do people use microservices? Because they read or saw a conference talk that it's the cool way of developing software.
Oh yeah.
People say that, yeah, it divides the responsibility, whatever. But the worst thing that you can do is when you are not following the Conway law. And Conway's law says that your like organizational structure and basically your should like your teams and your like projects in your code, they should follow your organizational structure.
Because
So,
these follow communication patterns, and
Yes.
as in software decisions and teams, communication is everything.
and if you, for example, you're a startup and you have like, let's say 4 or maybe 6 engineers, and you decide that, hey, we're going to use microservices because this is how people teach us, or how cool people at Netflix, what they do. And then you're like 4 of you or 6 of you start working on 10 microservices in parallel. So again, this is, let's say you kill your performance, you increase your cloud bills or whatever. If you're hosting in clouds, it's also an interesting topic to talk about. So basically, you're paying a lot more with performance. If you need to do pull requests on every microservice, and if you have a chain of like 4 microservices calling each other, goodbye productivity. So it's just nowhere near.
And by the way, we are laughing, but I think we could be as well crying, right?
Yeah,
Because this is such a serious problem.
I cry every day when I see it, and I see it too much. Basically, I see it nowadays. Like in the last couple of years, I see it in every organization, and that's so bad. The combination of these two is that basically you need to do a basic thing. So somebody from the business side, they say, okay, we have this app, we need to like display here a new field that comes from the database. Basic thing. So in a normal project, that would take me like, I would say half an hour at most, but maybe 10 minutes or something. And until I can even deploy it to production. But okay, if I have pull requests and microservices, so I go through in every service it needs to go through. I need to go and create a new pull request and wait until it's approved, until I can merge it and deploy it. And I will just spend wasting like maybe a couple of days actually adding this one field into all the places.
It's crazy.
Getting all the approvals and whatever.
And again, almost from the start, if you're just starting, you will most likely not split your domain correctly, which means these microservices are coupled. And as you said, it creates a chain reaction of PRs, which are all important to deliver. And yeah, you get yourself in a very bad situation.
And of course, the next worst thing is that when you specialize, if you have different people working on front end, back end, whatever, database, service A, service B, service C, then nobody sees the whole picture and nobody understands that there is a whole like chain of inefficiency built into your architecture.
I agree.
So for example, like in my current project, there is a cool thing that there is one service that was bought. It's developed somewhere outside. There is another like internal service that consumes the service there. So there is a library that is created that actually is designed to talk to the external service, and that's totally fine. But this library is in a separate repository. So basically, when you change it, you need to create a pull request and wait for it approved. When it's approved, you can start using.
You have to bump the package yourself, by the way.
Then you like deal with all kind of versioning and whatever. You create like a lot of problems for yourself. Then you go into the service, and then, for example, you consume the JSON API and you convert it into the gRPC format. So you create a completely different format for all your data. Usually still it goes one-to-one with all the fields, but in a different format. Then you convert everything into gRPC. Then there's another service which is like a gateway for the mobile application that actually does the gRPC call And of course, you need to do a pull request and get it approved before you can start using it in the next layer.
And now for one feature, one use case, you have at least 3 PRs.
Yeah, even 4, because you need to have the client, the mobile app in the end that needs to consume it. So once you go through all the chain of pull requests, you have spent already like maybe a few days, and then you realize that something is wrong. So
so again, here we go.
Yeah, you need to go through all the stuff again, and in the meantime, you don't have a working state of everything to just try it out. So if the whole chain works, because the stuff gets deployed only when it's merged after the pull request and reviewed. So it's really hard to run everything on your own machine also because of the so many dependencies and whatever. So it's just like you are shooting yourself in the foot with this kind of architecture. You're just making it, you ensuring that you cannot possibly go fast enough for the business requirements to be delivered fast enough.
I agree. And by the way, just for listeners also, like at least I will tell you my opinion on the antidotes for these two things. I mean, over specialization is a big problem, and I believe being full stack is the solution. For example, as much as possible, you should strive to solve problems as an engineer end to end. This is one, from front end to back end to database to everything. You need to solve the use case, build the feature end to end, and to understand, to be able to, and usually actually do it. And now for the microservices, I would say the antidote is always start with one service first. And if you want to modularize, well, there is a good concept called modular monolith. You apply your software design skills to create decoupled modules in your one repository, one service. And by the way, Sam Newman building microservices actually talks about it. You know, even though he's a proponent, well, he talks about microservices, but he says like, don't shoot yourself in the foot. Start with a service and modularize inside the service. Yeah, exactly. And this is where, because if the truth is, if you don't have software design skills to refactor inside one service to make it modular, you will not have skills to do it in a microservices environment where now you have distributed problems. And by the way, for that, you can read building data intensive applications. There are so many problems in a distributed world. So now you shot yourself in the foot. But this is my judgment of the antidotes. I don't know if you would agree
exactly.
with that.
That is what I'm always proposing. So you can in the same repo, if you can modularize, make the separate compilation units. So you get all the advantages of microservices that you can actually get. Maybe if you really have a huge project, you can get separate teams taking care of sub projects. But if they are still in the same repo, it's so easy to refactor. So you are not losing on performance.
Yes.
You can still have the compilation faster because you can compile the modules separately, and you don't need to recompile them all if you're changing only one. But you deploy everything together, so there is no remote calls where you waste your time. And if you need to move something between the services, it's just very easy. You just do it in your IDE. You drag stuff around. And then you can find what is the correct boundaries. And after that, if you really need to deploy something separately for whatever reason, and usually the reasons of separate deployment is that if something changes a lot more often and it's really, really isolated and you have a really separate people working on it, maybe it is a candidate for separate deployment.
And to add on that, you will already have if you do it well in your modular monolith, you will already have a well-decoupled module inside that service, which is not coupled too much to the other code. And that's, by the way, the first signal as well, right? If it's too much coupled, well, you cannot extract it, like by definition almost. But if it's decoupled and you now have either, as you say, it changes in different speeds, or maybe the team organization structure changed, now you can easily take this decoupled module from that service and deploy it separately, so to speak, as a microservice.
And even if you deploy separately, still you need to think about keeping it in the same code repo.
Yes,
because if things are related, if they change together, then it makes so much more sense. Then you fix or you help yourself not dealing with all kind of versioning issues. So
That's
which
a very good
version
point,
of
yes.
this service is compatible with the version of that service?
Because
Like,
you'll have to deal with APIs,
yeah,
right?
yeah. And then if you have in one repo, you just do one commit that changes the usages and the service itself, and you're done. You don't have to like spend a lot more like energy into like making it compatible or backwards compatible or forwards compatible, whatever.
All right. I would say let's wrap up. But it was a nice crash course of some maybe of the bad practices that we see in the industry. Of course, it's not always black and white. It's always a gradient. But at least we discussed
Sure, but
some of the
you never
problems
like
and
the things that I have mentioned. I would say like there is a reason to use them
Yes.
all. So any practice in software development has its own reasons, but most of the projects don't have these reasons, and especially not on day one, or maybe not even on day 360.
And may I ask on more like, as you mentioned, there's a lot of also the short media or YouTubes, and the problem is with the short media, I'm saying there are amazing things you can find on YouTube, but just to wrap up, in terms of book recommendations, right? If you read long media, it still gives you much deeper knowledge most of the time, especially if you reflect it based on your work and you do it continuously. Maybe just quickly, what would be your book recommendations for the listeners?
I'm still recommending to all the people new to software development to read the Clean Code book. So it's pretty old already, but it gets to the point very much. I think for my career it was like really like changing moment when I read about it, because I used to write very verbose code with many comments. I thought that the good code is the code which is really well commented and stuff. And then in the Clean Code book I realized that it's all wrong. So the code should be descriptive. You should be keeping it tidy. You should change it a lot. You have to refactor it. So I would say that Extreme Programming Explained, or take any maybe more modern book by Kent Beck, and the Uncle Bob. I think he's now working on a new book as well. So these are the ones that definitely are really essential reads.
Thank you, Anton. It was a pleasure to have you on the episode.
Thank you.
Yeah. I hope you enjoyed this episode with Anton Keks. And for the next one, I have a very special guest. And this guest is a principal engineer at Wise. Principal engineer is the highest status of engineer at Wise from the individual contributor career ladder. I believe only 4 or 5 engineers in Wise have this status. And I will have an honor to talk to one of them very soon. I'll keep the name of the guest private for now, but feel free to subscribe to Map for Engineers at your favorite platform, Spotify, Apple Podcasts, or Substack, YouTube. And you'll get to know about the episode very soon. See you soon. Thank you.